Okay, welcome everyone. We are in week 5. We are studying chapter 3. So today in the next session, as I mentioned in the recorded video, uh, we are gonna finish the chapter 3. So for sure next week is the exam week. So today we are gonna talk about the relational data model. Okay. So in this chapter, we are gonna cover some concept again regarding the relational data model, which we already talked about most of them so far, but today we are gonna go through more details. We are gonna learn about uh, the relational data model itself. What does it mean by relation? What does it mean by attribute? What does it mean by the diagram related to these attributes? And also, we go through the different type of keys. We already talked a little about the primary key, foreign key. So those things we'll learn what does it mean by composite key. We will learn about what's the surrogate key. That's the type of things that we will learn. And then the normalization process, the one that, as I mentioned, you are going to have it in the recorded lecture this Wednesday. So again, after we come back to the class, we'll again review those. So the normalization process, what does it mean? And what are the process for doing the normalization? I will go a little through the normalization today, but again, the main part is going to be through the video that you're going to watch later. So the logical relational data model, what does it mean? So old days, there was a database, but not in the way that we are using it right now, in a version of the logical version. So in the old days, they had to store all the data, but they stored all the data through the disks. So it was totally physical. And for each disk, if they wanted to connect a couple of data together with the disk, they use the pointers. Okay. So for sure, these are just some information to know. There is no, I would say, necessary or critical things to understand, but just it's good for us to know that how the data would be handled in the uh, old days. So they use the like a pointers to address the disk together and some indexes in order to address it. So for example, right now we have a table for the students. We have a table for the, I don't know, grades. But back then it was a disk. So they use those type of indexes to address each. And we can just say that there were a lot of issue with this type of databases. First of all, they were really exposed to a lot of danger. I don't know if the disk was broken by whatever reason, natural reason, whatever reason, all of those data would be gone. So definitely keeping the data secure was not the easy task before. So then this guy, the Mr. Cod, Edgar F. Cod. So technically, the reason that we are doing this course today is just because of this man. So he created the logical version of the database. So he came with the idea that we can do this type of database through the online system and then the logical design of the database. So all through him. So again, by removing those physical version, they just wanted to make sure that the data sets is protected and they can, for example, update it easier. So back then, if they wanted to change, for example, something into the disks related to the students, they had to rewrite everything from scratch on the disk. But nowadays, we know that with just the update function, you can just easily update your table without any issue. So that's why this person, he came with the idea of the relational database system. So that's why they called him the father of relational database management system. But let's talk a little about what does relations means to us. So we already talked about it. So we mentioned that in the very first day, we had that example of the books and the authors, or in the academic system. We mentioned that, for example, there is one thing, one entity, one table, or we call it as a one relation as a student, which you are. And there is also another thing, another entity, another uh, relation, another table, which we call it, for example, as a faculty. I don't know. there is also another thing for just the staff, and a lot of more possible tables. So each of these tables that we know right now, what does it mean by table? We know that the tables that we have the attributes, and for each attributes we can insert data. We call these relations. It's just a name. It's a table. We call it relation. That's why when we connect these relations together, we have a relational diagram. Okay. So again, it's just a name. Nothing changed. The table that we have so far, we call it right now as a relation. Okay. So let me open it. So as I mentioned, we call this table as a relation, and this relation, it's like a two-dimension table. We already know it. It's a table with the attributes. The attributes which we mentioned that each attribute can define the the relation itself, can define the table itself. For example, for the students, first name, last name, student ID, email ID, whatever. Okay. And then each rows which related to one specific student's information. Row one for this student, row two for this student. So technically, each of them could be considered as a row and a column. So that's what we call it as a relation. Relation, it's just a table. And again, each relation has the attributes as column. So each of these column, which we call it as an attribute, the point is the order, does it matter in the table or doesn't matter? It doesn't matter. It doesn't matter if it's a first name, last name, blah, blah, or last name, first name. But we always make sure to have some order to understand it better. We always go, for example, with the first name, last name, and all the related information. So for example, maybe it's just a not good idea to start the form with the phone number at the first call. Okay, again, it depends on you, but there is no mandation for having the order. But the things that should be always make sure to take care of that each column should be unique. The name should be unique. You cannot have two first names in the table, because when you are importing the data, if you have two first names, technically it doesn't work. All the names should be unique. If we're going to the domain, the tuple, the one that we mentioned as a tuple, tuple means just each rows. Tuple one, the row one is for a student name XY. Tuple two, the row two, again, it's for the student ZW. That's it. So again, bless you, the order again in that one doesn't matter. And the point is, no two tuples can have an identical set of value, which technically we will learn it by primary key. This one is not possible. You cannot have two rows with exactly identical values. We will see why we cannot have it. First of all, if you have it, it's like a duplication, so you have to remove it. But again, according to the primary key that we will learn, it is impossible in a right table to have two rows with the same exact information. We will learn it. But regarding the domain, so for example, we have this table for the faculty, the first name, last name, and then the phone number. Okay. We know that right now for the phone number, we will always have integer values. We will have numbers. We don't have alphabets in the phone number. For the first name, last name, we know that it should be just through the alphabetical list, A, B, C, D, whatever. Okay. The point is, we will learn later. When you are creating a table in the SQL, in MySQL, for the first name, you will say, for example, the first name, the type of the first name is character 30, which means you will allow the table to have the character up to the 30 characters for the first. For the last name, same, for example. But for the phone number, you will see int integer. So technically, the domain that you are defining is let you to just put the related information to each column. The point is, first name, last name, they are both character. They have same domain, but for sure, different attributes name. Okay? So there are just some obvious things. We are just naming them to understand them better. So far, relation, that was a table that we have already worked with. The attributes, we already know. Those columns we call as attributes. Each row, the term is new to us, tuple. The tuple is exactly each row in an instant. And the domain, again, just we need to know that for each specific attribute, the domain should be exactly same for all of the data that we are entering under that specific attributes. And the null value, as we talk, what does it mean by null value in a data set? We mentioned about last week in a null value. Nothing. We have no idea what is it. We don't have the data for it. It doesn't mean it's a zero. It doesn't mean anything. It means we don't have information for it. If, for example, there's a zip code for the faculty, if you don't have the information, just leave it as a null value. And again, we will learn null value when you are going to create a table. You will just name it as a null. You cannot put it in the quotation because it will consider as a text in that case. So for the chapter 2, again, the assignment 2.234, as we mentioned, you had to create some table. And I also post an announcement for it in order to just more clarification. For the second part, you had to insert something to that table. And for those that you don't have information, you just had to just write no. Okay? So the way that we write a table is like this. Let me just write this. So for example, if the relation is faculty, table name, relation name is faculty, that's how we write the database schema. We need to learn it. How we can learn it? Easy. The table name, what is the name of the table? Faculty. Then you have to open the parentheses. What are the attributes? First name, then last name, then, I don't know, employee ID, then email, okay? And just close the parentheses. That's the way that you just technically introduce in a database that this is a table with the faculty name, first name, last name, ID, email, whatever. They're all related attributes for each faculty in this table. So as we see here, that's the like a normal table that we have already. So again, each rows we call it as a tuple. The columns are the attributes. The domains, as I mentioned, for each column should be unique. But let's talk about the key. So as I mentioned last week, Probably do you remember what was the primary key in each table? Why we need to have a primary key? Can you just give me some information? So you use the primary key and like a foreign key to connect the table. But itself, what does it mean by primary key in each table? I just went through very quick, please. The main key that defines the unique identifier in each rows, okay? So technically for each relation, for each table, you need to have one specific column, one specific attribute to identify that table. What does it mean? Imagine this is the first name, last name, employee ID, email, okay? So in this specific table, which one of these attributes, first name, last name, employee ID, could be a unique identifier for me as a Hossein Mohit in this organization? Why? As a unique identifier. My name is Hossein. There might be another Hossein in this organization. So if you know Hossein, if you go to this table, there might be at least another Hossein in this institution. So you cannot define it. You cannot find it which one is related to the Hossein. The last name is the same. My name is a little unique here, but imagine David Gerard. So technically there are a lot of David, there are a lot of Gerard, so they cannot be a unique identifier. But the employee ID, which is generated by a school, for each employee is the unique number. So if you know that 11297270 blah blah, if you know this number, you can just easily go through this table and find it. This is related to the Hossein Mohit with this email address. You see, that's the thing that we call it as a primary key. But the point is, in each table, there is a possibility that we have more than one primary key. We can name it as a candidate key. So there are multiple keys that each of them you can consider them as a primary key. So technically, that's your job to choose which one you would like to go as a primary. So for example, here in this specific table, we have the course ID, department, course number, course title, credit hours. So if you want to go and find the primary key in this one, which one you would select it? Course ID. Department, it could be possible that you have duplicate value for each course. The same for the course number. There is a possibility that you have, for example, math 100, and as you can see, accounting 100. The same for the course title, credit, but the course ID itself could be considered as a unique value. But for example, in this specific faculty table, if I had social security number as well, in that table, now I can nominate two keys as a primary key. One is the employee ID, one is my social security number, which is unique to me, okay? So technically, these two considered as a candidate key because they can be a unique identifier in each row. But I just, for example, go with the employee ID as the primary key, okay? That what we call as a primary. But sometimes you cannot have only one primary key in a table. Imagine we have a table for the academic system. We have a table like enrollment table, okay? In this table, imagine your student ID is 100 and you are taking class X, and at the same time, a student 100, which is again you are taking class Y as well. This is the enrollment table. And the course name and the class location, whatever. In this specific table, if I just mention a student ID is the unique, this is not right, because we have another student ID 100 here as well. If I mention, okay, the course is unique, no, this is not right. But the combination of the student ID and the course ID is the unique composition in this table. So right now we can say we have the composite key. The composite key, which means two attributes, two column, they are working together in order to uniquely identify one table. Was it clear? What does it mean by composite key? Yes. Itself, they cannot representative of the unique identifier, but with the combination of the other, they can be considered as a unique identifier. We will see more we'll see more example in the following slide. Other keys that we can have it as like a primary key, surrogate key. Technically, it's just a system that generates codes itself. A student ID 1, 2, 3, 4, 5. The system automatically generated for us in order to not having error later. You might creating a table for the students, and you might forget to, for example, put the unique identifier attribute for it. But if you just easily at the time of your creating table, mentioning that, okay, I'm gonna put a surrogate key. The surrogate key is the student ID. So the system itself, whenever you're entering the new rows, it will generate one new code for you, which is not repetitive, it's a unique. So again, just a technique to make sure that, okay, now in our table, we have a unique primary key. And the external key, again, that's a type of key that they have a real world meaning. SSN is related to someone real in the outside. So if you're using the SSN, so technically these surrogate key and external key are like a variation of the type of primary. When you're using a student ID, technically the system itself generates a student ID. And when you're using the SSN, it's a specific number for this person in the outside. But foreign key, as I mentioned before, whenever you're creating a table, you have to have the primary, okay? In a relational data model, the one that we had in the Red Cat database that we watched, we saw the tables. So in order to connect these two tables together, you have to have a common attribute, common like a columns in each. So technically, when a primary key in one table appears in another table, that primary key will be considered as a foreign key. In this specific example, right now, grading course, a student ID is a foreign key or primary key, is a foreign key that technically refers to the student table, right? So technically, foreign key is the key that you can, from that table, find the reference table. Here, the course ID is the one that technically refers us to the course table. But right now, in this table, grade in course table, what is the primary key in this one? Course ID. What is the main condition for being as a primary key? They should be unique. Course ID 7, course ID 7. Are they unique? No. Okay. So which one is the primary key in this table? A student ID. A student ID. Again, the main condition for having a primary key, which means the values should be unique. Always remember the SSN number. My SSN will not be in any way same as your SSN. Okay, so it's a unique. In this table, a student ID 1, you are right. A student ID in the student table is unique because each row is related to one specific student. But this is a new table, grade in course. So which means you, as a student, what is your grade in this course? So right now, one more time, what is the primary key in this table? Pay attention to this fact. For the primary key, you cannot have repetitive values. Which column or combination of which columns can be a unique identifier for this table? Student ID and the course ID. We just talked about the composite key. The composite key, it's the combination of two keys that itself, they cannot representative of the unique identifier, but together they can. Right now, you cannot find any combination of the student and course ID that have the repetitive value. Impossible. Logically, it's impossible. You, as a student one, you will just be in the course ID 7 once. You cannot be in the course ID 7 twice in this table, right? So in this table, the combination of the course ID and the student ID will be considered as a composite key. This is so important to understand the composite key because in the normalization process, in the second norm factor, we will learn. In that one, you need to understand the composite key. Any of you, just tell me what does it mean by composite key one more time. Please, you know it. Don't be shy, tell me. Composite key. Hmm? Okay, each of them can be a unique identifier in that table or can't be. By themselves, they are not. So right now, exactly, in this table, a student ID itself, again, in this table, always look in which table you're discussing. A student ID in the student table, yes, that's a unique identifier. Course ID in the course table, yes, that's a unique identifier. But in this specific table, a student ID plus course ID is not a unique identifier. The combination of them can be a unique identifier for that table. Okay? Again, me, faculty, ID 1, I can have course A, course B. So in the enrollment table in the school, they will put my name as a faculty ID and the course ID. Faculty ID 1, which is me, I can have multiple courses. So you will see faculty 1 repeated multiple times in that table. And also course ID A also offered by different professors, but the combination of my name and the course name can be a unique identifier for that table. So how you would know it whenever you go through the tables, just check column by column, and based on the logic you have, you will understand it. Okay, this column could be a unique identifier or could not be. The main And the only condition for being unique identifier, it means that you shouldn't have the repetitive value for that specific column. Again, if you want to just remember, always have the SSN number example in your mind. SSN number, it's always unique. You cannot have two SSN number for two identical SSN number for two persons. Yes. Technically, the foreign key is the primary key in another table that you are repeating it in order to just connect these two tables. Okay, as you remember, in that Red Cat database data set that we had, for example, the sale table and the customer table. Okay, for the sale table, we had sale ID, the type of category, whatever. For the customer ID, we had customer ID 1, which was Hossein Mohit, blah, blah. Okay. So in order to connect sale ID to the table ID, we have to put the customer ID in the sales table. Then I can understand, okay, the customer ID 1, which purchased these items, is related to someone real into the customer table, which we call it referential integrity. We will talk about it later. But that's the way. So we learned here that if you are naming faculty, if you're writing a faculty in a database schema, you have to write the table name first, parentheses, and then attribute. When you know which one is the primary key, you just underline it. So right now, when you see this line, you would say, okay, this is the database schema. So that's a relation. That's a table. What's the table name? Faculty. What are the attributes on it? First name, last name, employee ID. Which one is a unique identifier? Which one is the primary key? Employee ID. And if there is a foreign key, you just need to write it this way. Right now, this is the table, a student ID, a student number, first name, blah, blah. And you can see we underline the student ID because it's the unique identifier, primary key. The same for the course as well. Course ID, we are highlighting, we are underlining it. But in the grading course, since we have the composite key, we have to underline both a student ID and course ID. And we need to write, okay, foreign key is a student ID, which references the student table, course ID, which references a student course table. So that's the way that you need to know how to write it. In this section, we are learning when you have a table, write this way. Later, we will learn when we have this one, how we can create a table, okay? So again, that's the table itself. So you see, if I give these 3 lines to you itself, you should be able to draw the diagram. How? You will see, okay, there is one, let me clean it. Let's do this together and then we'll see how it is easy. So imagine you are just having this database schema. Okay, so the first one, what's the table name? Students table. What are the keys? What are the attributes on it? Student ID, student number, first name, last name, and blah, blah. So which one is the primary key on this one? The student ID. I just draw a key. The next table. What's the table name? Course ID. What are the attributes? Course ID. Then department, course number, and blah, blah. Which one is the key attribute on it, primary key on it? Course ID. One more time, what does it mean by primary key? It's unique identifier. So whenever I have the course ID, I can easily go and find the related information. Okay, what is the other table in this specific example? Grade in course. What are the attributes on it? Student ID. Then grade. What is the primary key? And the course ID. We have the composite key. Again, itself, we cannot, just again, always look at the table. If I have a student ID in this table, a student ID 1, can I exactly mention which rows just related to that student ID 1? No. Why? Because a student ID 1 can have a course A student ID 1 can have a course B. Like you itself, you have 2 or 3 courses this semester. So in this specific table, if I have just a student ID 1, I cannot uniquely identify each rows. But if I know a student ID 1 take IS 3280 class, so right now I can uniquely identify each row. Okay? Okay? So is it clear by composite key? Because we need to learn it. We are going to use it later. The composite key. Composite key matters for us. Whenever you cannot uniquely identify a table by a specific one column, which means you need to have another column as well in order to have a primary. Okay, right now, how can I connect these two tables? I have to read it. The foreign key here, a student ID reference student. So which means I can connect it this way. And then the course ID this way. Before this section, this session today, we had this table. And then when we wanted to ask query, we would say select asterisk from a student table, okay, join grade in course table on a student ID from a student table, a student ID from grade in course table. Or this way, select asterisk from the course table, joining grading course table on course ID from course table equal to student ID from the course ID from grading course table. Okay, so that's the way that we write it as a database schema. You need to know how you can transfer it to the relational model. So each of these table, what we call them? Each table, what we call them? Relation. Each attribute, each column, we call it attribute. Each rows, we call it tuple. Okay? So again, that's the way that we can just show the reference. So here again, the Redcat database that we have. So for these, for example, we can write for the first one, sale table, parentheses, sale ID, is it primary key? Yes, underline, then the rest. And also the same for the rest of them. For example, the product table, what is the primary key? What is the primary key product table? Product ID. Do we have any foreign key in this table? Manufacturer ID. Manufacturer ID technically is the primary key in another table, which is the manufacturer table. So that's how the primary key and foreign key works. So each table you should have a primary key. Okay, you should have a primary key. And then in order to connect to other tables, you should also have the foreign. But primary key is the definite thing. You should have it. Can we have a table that technically there is a possibility that do not have a foreign key? Can we have? Yes. Right now in this example, customer table, there is no foreign key in the customer table because you don't need to connect it other table. We don't need to have other tables that refer to this table. Okay. So here the customer it just have primary key. Primary key is a should, is a must. You should have it. But foreign key depends on the way that you are creating your database. You might need it, you might not need it. But two important concepts that you need to understand it well in order to do the normalization. Okay? But before going through this, let me go a little through the normalization, the one that you are gonna watch the video for it. If you remember, we started chapter 2 with only one table. You remember that? We just started with the simplified sales table as an example. And then next week, I came and explained that, okay, for example, if you just have one table, and if you want to have Hossein Mohit as a customer in that table, if I purchase 1,000 times in each year, you have to write my name 1,000 times in the table. So waste of time, waste of energy, increased error, and also occupying a lot of storage. Then I mentioned why not having another table for the customer that put Hossein Mohit as a customer one, and each time in that table, refer Hossein Mohit as a customer ID one. So technically, another table, which the primary key is customer ID, and use the customer ID as a foreign key in the sales table. You remember all of these, what we have discussed? I remember that day that I mentioned that we call this process as a normalization. So technically, the normalization is the process that we should go for in order to make sure that the number of tables that we have here, they are the right number. We are not going to have any more. We are not going to have any more table, or sometimes we can combine some table to have less table. But the process that you can have, okay, at this point, all this table according to these conditions, which we name it first normal form, second normal form, third normal form, and sometimes fourth normal form. When you watch the video, you will understand. The first, second, and third. When you meet the third normal form condition, you would say, okay, now I have the database that are normalized. Okay? But before going to that level, you need to understand these two constraints, which we call as an integrity constraint. Let's read it from text and then discuss what does it mean. Entity integrity. Because of the primary key that should uniquely identify each table, or technically each tuple, each row, it cannot contain null value. What does it mean? So I have a table. The table name is a student. Give me some attribute for the student. A student ID, first name, last name, and email. So what is the primary key in this table? Let's remove the email because you might say, okay, email is also unique, which is right. A student ID is the primary key. Why we need to have the primary key again? In order to identify each row. If I have your name, if I have our name as a name in the student table, there is a possibility that another student with the same name are in the table. So I cannot identify uniquely the information related to our, okay? But if I have the student name, a student ID for this student, which is, for example, student ID 123. When I go to the student table, I can say, okay, a student ID 123 is related to this specific student. So that's the nature of the primary. Again, we are just repeating it. But we have a student ID 123 just to the whatever. Imagine in this specific table, which a student ID 2 is related to the student A first name, the last name is B. Imagine for whatever reason, I don't have value for it. How can I identify this student in this table? Never. I cannot identify it. That's the reason that we have to have primary in order to identify it. So that's the main rule, one of the main rules that you need to know, which we call it as the entity integrity. Primary key always, always, always should have a value. You cannot have the primary key as a null value. So when you go through the video for the next session, you will see the first normal form. It's saying that the primary key should always have the value and should have a unique value. So when you have a table that the primary key have the value and are all unique, technically you are in the first normal form. I'm not going to that, but just giving you some heads up about the first normal form. What does it mean? So that's the critical assumption. If there is a table that there is no specific value for the primary key, technically you are violating the entity integrity. You might ask, okay, what if I have the composite key? What was the composite key? What was the composite key? Two attributes together that describe. So if you have the two attributes that together describe the primary key in that table, those together, they should always have value. In this specific example, the student ID, course ID is the composite key. You all agree? So when I see this table and see, okay, there is no value for this. There is no value for this. I just right away would say, okay, this table violates the entity integrity. So again, in the course that you're gonna watch, you will say, okay, this table violates the first normal form. Technically, there's an issue with this table. We have to take care of it. Okay? So that's the way that we have to always make sure that we are not violating entity integrity. Every time, whenever you have to import your data for each row, for the primary key, which could be just one single column or combination of the multiple column, that one, all of them always should have a value. Okay. The second one, referential integrity. Every foreign key must either be null or must be an actual value of a key in the reference relation. What does it mean? Sale, table, okay? then customer table. Okay. For the sale table, we have sale ID and I don't know, the category, date, and I want to know which student, which customer purchased it. Am I right? So I need to have also the customer ID here as well. We have customer table as well. Customer table, the attribute, the primary attribute is, primary key is customer ID and first name, last name, blah, blah. What is the primary key in this table? Sale ID. What is the primary key in this table? Customer ID. Customer ID here is a foreign. According to the entity integrity assumption, the first one, we should make sure always there is a value for sale ID and the customer ID. That's the first rule. You always have to have a value for it. But in the sale table, is it possible for whatever reason for whatever error I sold to someone that right now I'm not sure about the detail of that person? Is it possible in the system? I sold to you and I forgot to put your ID in the table. It's possible. So you can have the null value here. It's possible. For error, the person forgot to, for example, ask the student ID or whatever. But in this table, when I am filling the student, the customer table, it's impossible. It shouldn't be not have value for the customer ID. So technically, here, foreign key in this table, it can have a null value. It is okay. But if it has a value, definitely it should refer to something real in that table. You cannot have the customer ID 2, but not having information for customer ID 2 in this table. It's impossible. It shouldn't be. Everything is possible. It shouldn't be. So technically, if there is a customer ID 2 here, which I don't have a value in the customer table, I am violating the referential integrity. Okay? Example again, in this specific table. A student ID 1, customer ID 8. Let's go back to the original table. Do we have any, sorry, course ID. Do we have any course ID 8 here? It's 5, 6, 7. So technically that table refers to something which is not existed. It's referred to the course ID 8, which course ID 8 is not defined in the course table, right? Are you with me? So that's the referential integrity. So two important rules to know: entity integrity and referential integrity. The entity integrity, which means whatever primary key you have, either single column or it's a composite key, they should have a value. You cannot put it as a null value. Referential integrity, when you are referring to some table through the foreign key, that foreign key, it's okay to be null, but if it's not null, it should be related to something that exists in that table. You cannot have, again, example, you cannot sell to customer ID 2, which the customer ID 2 is not existed in the customer table. Okay? So that's a referential integrity. Any question? For the normalized version, yeah. Again, when you watch the video, you will see. We have to make sure that whenever we can claim that we have a normalized database, technically, we have to make sure that we are on the third level of normal form. The first one I mentioned, always the primary key should have a value. The second one, again, is related to the referential. The third one is another thing. So you will see when you watch the video, you will see. And for sure, if you have a question again, I will again, when we come back for after the week 6 exam, I will go through them again. Let's see some example. So in these three tables, identify primary and foreign key two in the employee table. Let me just what are the primary key in the employee table? Just employee ID, yes, no, yes. For the position table, which one is the primary key? Position ID. What are the position title? No. What are the combination of the position ID and position title? Yes or no? When we have some column that can be considered as a primary key, we are not looking for composite key as at all. We have a table, we have a column. Position ID is a primary key, done. We don't care about the combination of the others. Okay. The location ID. So technically in this table, it's easy. There is a surrogate key that system is generating for each one. It gives a unique ID. That's the easiest way to always make sure that the primary key in your table have a value without any doubt. When you're creating table in the SQL, you would say, okay, surrogate key, always generate a unique value for your table. Okay, so definitely you don't have any problem. You won't have any problem. And identify whatever foreign key you see in these three tables. Which one? And in which table? So position ID refer to which table? And location ID refer to location. So in order to create a schema for this one, we will write employee parentheses, employee ID, underline, employee name, blah, blah, position table, parentheses, position ID, position title, degree required, position ID is the primary, and also for the last one, location. So that's the way that we need to write the employee schema, yes. Employee phone as the primary key. I don't know, this is possible here in my hometown, in my country. People can sell their phone number to the other people. Is it possible here? It's possible. You can sell your phone number to other people. So in that case, maybe there is one employee that have one specific phone number, and that person sell it to the other employee. So in that case, that column could be not unique. So technically, we are always looking for the cleanest one, the one that there is no doubt that this specific attribute is unique. And I love the way that you think, because that's like a critical thinking. You are checking column and see, okay, now what about this? What about this? that's the time that you can say I'm learning it. That's a critical thinking. That's a skill that unfortunately right now is impacted by generative AI tools. I myself is one of them. Okay, so I'm talking about myself because we sometimes we are not in the mood of thinking and said, oh, what do you think about this? And it gives us the answer. So technically, we are just in a way that we are not thinking anymore, at least not enough to have like a challenge our mind. That's a critical thinking that we need to know. That's an important skill that I would say still no one clearly teach it in the school, which technically is not possible to teach critical thinking because that's a skill that you need to just find it by yourself through the whatever course, whatever action that you are doing. But let's get back to the course. So yeah, it should be always something very clean, very unique. So if you have this schema, now you know how to draw the relational diagram. So you would create a table for the employee, position, location, and connect the employee to the position and location table through these foreign key. A university database track information about the students. These are the names. And these are the attributes, ID, name, major, blah, blah, professors again, and the sections again. Create a set of relation for this database and a schema for the relation you build. So for the first one, for the student table, through the questions that we had, so student ID, student name is the right name for it, right attribute for it, and the student ID is the primary key. Professor, same. Course, same. The section ID, course ID, section number, and the professor ID, and the enrollment. Okay. So in the section table, which one can be just a primary key? Just section ID. Maybe I made error and forgot to put underline on the course ID. What do you think? Maybe I'm just trying to give you some false information. Since the section ID itself is exactly related to one section that already assigned with the class, so technically you cannot have two section ID with the one unique course. Okay, so that was also unique. So that's a primary key. But regarding the enrollment, again, we will have the composite key because students section ID itself is not unique in this table. Again, always check in which table you are looking for the primary key. Section ID itself is the unique primary key in the section table. But here, section ID is not unique because there could be multiple sections that there could be one section that related to multiple students, right? So the combination, again, is the unique version. So that's the, again, class schedule schema. So again, a student, professor, everything, we need to make sure to have this one. And just let you know, we will not have any like a exam that I ask you to write the database schema for me. No. Again, for the first exam, which is next week, you just have to go through the exactly like assignments too. Okay. But again, I need you to understand it. When someone show it to you, okay, this is a database schema. I just want you to know, okay, the first one is the table with this attribute with this primary key. The second one is the same. This one is the section table with this specific primary key with this attribute, and these two are the foreign key that refer me to this specific table, refer me to the course table, refer me to the professor table. That's all I want you to understand, okay? And the other one, Dunkin' Donuts orders several products from various vendors. They have a contact person and each vendor side along with all of either address information. Each purchase order has the order number. So this is the table, purchase. Order number, date, blah, blah. Product table, product information, include stock number, description, price. And this do not send a check for payment and record the check date. Create a set of relation. So the first relation, the first table I have is the vendor table, which is the vendor name, vendor number, vendor name, vendor address, and the vendor number is the, what is the vendor number in this table? Primary key. Again, order. Order number, again, is the primary key. Stock number, like a product ID. It's a product, it's the primary key for product table. And then we have the product order, which is the order number plus the stock number, and then the payment, which is the check number plus the date. That's the way that you can write. So very quick for the, when you go through the chapter, the part for the Wednesday, you will learn about the normalization. Okay, so in the normalization, we have the example why we need to have multiple tables for each table. And then we have the first normal form, second, third, and the explanation for each is here, okay? So again, you go through it and just at the end of the video, I also went through the assignments for this chapter and try to explain it. So let me stop recording and tell you one thing, and then you're okay to leave. Okay, welcome everyone to the second part of the lecture for this week. Today we are gonna finish the chapter 3. So we are working on normalization and continue to what we discussed on Monday. So let's start with the normalization. So again, the same example that I've already repeated multiple times. We're gonna have it one more times again in order to understand why we need normalization, why we need table decomposition. So we will see. So the example that I already mentioned multiple times was the, for example, we having the sale table with the first name, last name, and rest of information. My name there, Hossein Muhit, as a one of the customers. So imagine I am purchasing thousands items in a year from that company. So they have to enter my name 1,000 times. So if they put my name wrong, they have to go and fix it 1,000 times. So that's a lot of data redundancy. So we mentioned in order to address this issue, we can have one extra table as a customer table. We can put the ID 1 for the Hossein Mohit, and each time instead of inserting my name 1,000 times, so we can just put my ID, which is ID 1. So technically, in this case, we are inserting my name only one, and there is no extra data, no waste of time, no waste of energy, no waste of memory, anything, okay? So that's what we need to have the normalization. So by normalization in a database, when we claim that our database is normal, which means there is no data redundancy, there is no further issue by adding data, there is no further issue with the updating data and deleting. So all these anomaly that could happen because of the not having a normalized database, we are gonna address it. So in order to be in a normalization process, we need to go through three different standards. We will see them. So if you remember, we started chapter 2 with the first table, which we call it simplified sale table, all the information, and then we came to the conclusion, okay, we have to have multiple tables. Okay, so that's why for the rest of chapter 2 we worked on different tables that the combination of these tables together, we call them as an entity relationship diagram. So there is a relationship between each of these tables, each of these entities, each of these objects. Okay, so now let's go for designing a database. Then at the end, we can claim, okay, we have a normalized database. Okay, so we will start with one important definition, functional dependency. We have to first understand this one. And according to this, we will go through the first normal form, second normal form, and the third normal form, which is the most important one, is the last one. So by functional dependency, imagine, for example, we have A to B. So in this case, we will say A determine B, okay? Or B is dependent to A, okay? So let's go back to this example. Here, we have sale table. We have sale ID as the primary key. Sale date, customer ID, product ID, quantity, tax, shipping, all rest of the attributes, rest of the features in this table, okay? Do you agree if I just have sale ID, for example, sale ID 100, if I go to this table, I can see the rest of the information? Yes. So technically by sale ID 100, I can determine the rest of the attributes. Okay. But if I have just, for example, February 2, 2024, can I determine the rest of the information? No, because for sure for the February 2nd, 2024, maybe there would be thousands of transactions, thousands of rows. So technically, we cannot determine the rest of them, okay? So unique identifier, that's another case for it. When we have the unique identifier, according to that one, we can definitely determine the rest, okay? We call these things as a functional dependency. So technically, for example, when you have the manufacturer ID, you can determine manufacturer state, okay? And we can say that the manufacturer state is dependent to the manufacturer ID, okay? And we need to always make sure that when we are saying X determine Y and Y dependent to X, okay? So the item on the left side, we always call it as a determinant, okay? So this is a general concept of functional dependency. We will see how we can use this in the second normal form and the third normal form. So any question regarding the concept of the functional dependency? Is it clear? What does it mean? No question? One more time. When I have sale ID, for example, I can determine the price of that specific transaction, okay? So price here is dependent to the sale ID, okay? Sale ID determine price. Price is dependent to the sale ID. So that's the functional dependence. Now we know what does it mean by functional dependence. Okay, am I right? So let's start the normalization. So we have first normal form, second normal form, and third normal form. Okay, These three are the most important thing for us when we are talking about the database normalization. Okay, technically we will see when our database is in the third normal form, automatically address the second and the first normal form. So when we can claim that our database is in the third normal form, we are good to go. So we can say, okay, now we have a normalized database. Okay, one more time. The main reason for having a normalized database is to avoidance of any type of data redundancy, any type of anomaly when we are inserting data, deleting data, and updating data. Okay? So let us start with the first one, first normal form. For being in a first normal form in the database, there is a one single rule, which is all attributes in a table, all columns in a table, they should have only one value in each cell. There must be atomic, which means in this case, employee name John, Mary, Luan, the name is just one. But when I go to the skills, we can see there's a programming, there is a query optimization. This is wrong. We can only have one value. We cannot have two values on each column. In this case, we can say this database is violating the first normal form. Okay? So in this case, we have to address it like this. So we can have the John, and we can have the skills in the two different rows. So that's the only way that we can address this issue. So one more time, in order to be in a normalization process, in order to claim that, okay, we have a normalized database, we have to go through three different conditions. First normal form, second normal form, and the third normal form. Now we are addressing the first one. By first one, which means all the values under column, under each attribute should be only having one attribute, one value, not more than one. So right now, programming and query optimization is wrong. But maybe you would say if the name has two parts, it is fine. That's the one name has two parts. Like for example, some Persian that has two parts. But here we can see there is two different value under the skills column. So this is the first normal form. If you have multiple values, you are violating the first normal form. Okay? So this is the first one. Was it easy? Yes? Simple. Just by reading the data, you can very quick understand, okay, there is a multiple value, so now the first normal form is violated or no, it's checked. Let's go to the second yes. What is the? Okay. Oh, where is it, you mean? Oh, we just didn't put it. We have John Mary. So because we didn't have more space, yeah, we can have Loan, and for the Loan, we have to have three different. Okay? Good eye. I didn't check. Now, let's go. Okay. This is the table that we have. What is the primary key in this table? Is the student ID primary key here? Think. So can we say that just by having a student ID, we can identify each row? But if I have a student ID, which is, what's your name? Mario is the student one, okay? And what if you have another course, which you have multiple courses? So if I just have your name, can I determine exactly which row is related to you? We can't, because this one uniquely is not going to uniquely address each row. But when I have the combination of a student ID and the course ID together, we can say we have the unique identifier for the row. Okay, one more time. A student ID1 can have multiple courses, am I right? So a student ID1, fourth row, can have, for example, course ID 8. If I just have a student ID1, am I able to say which row I'm addressing? No, because row 1 could be the one, row 4, row 5 could also be the one. But if I have the student ID1 and the course ID, you cannot take one course 2 times in one semester. So a student ID1 and course ID7 uniquely describe the row. Okay, so we have the composite key. Am I right? So what was the composite key from the previous session? What does it mean by composite key? How many key we had? So the combination of two keys together, they can be a primary key. So each can be a candidate key, but together they are describing the whole data, the whole row. So they are technically, the unique identifier is the combination of the two or more than two keys. It's not just, it shouldn't be just one, two, exactly two. It could be more than two. So in this example, when we are talking about the second normal form, let's read it from the first line together. No non-key attributes. Non-key attributes, which means in this case, the student name, credit hours, and grade. Am I right? Because student ID and the course ID are the composite key. So the non-key attributes here could be a student name, credit hours, and the grade. No non-key attributes can be functionally dependent on only part of a key, which means when we have the composite key, here we are talking about the functional dependencies that we just learned. When A determine B, okay? So here, imagine the A is the primary key. Now we have, for example, A and C determining B, okay? This is the composite key. So technically, if we have a composite key in our database, the dependent should depend to the both of them, should be depend to the whole composite key, not only part of it. If it just depends to the part of it, it's a violation of the second normal form. Let's see from this example. Here, if you have the student ID, you can determine the student name. Am I right? Yes. If I have the course ID, I can say what is the credit hours for it. Yes. The point is, here, if I have the student ID and the course ID, I can say there is a grade. But the issue comes from the credit hours is just dependent to the course ID, is not dependent to the student ID. Again, one more time, we have the composite key, a student ID, course ID. No non-key attributes, which means these three. They should be dependent to the whole key, not part of the key. Okay? Here, the credit hours is just dependent to the part of the key, not the whole key. That's why we have the violation of the second normal form. One more time. When we are talking about the second normal form, most of the times it's more related when we have the composite. What does it mean by composite key? When we have more than one key to combine together that they can describe uniquely the table, okay? There is a rule, no non-key attributes. So whatever attributes that are not key. Here, a student name, credit hours, grade. They should be dependent to the whole key, not part of the key. Here, credit hours is just dependent to the course ID. It's not dependent to the student ID. Okay? So technically, credit hours is just dependent to the part of the key, not the whole key. That's why we have the second normal form that is violated. Clear? Yeah, go ahead. Dependent. So be. So when you're talking about the, let me tell this way if I understand your question correctly. So in this case, we said A determine B, okay? And B is dependent to the A, okay? When we have multiple keys together as a composite key, this B should be dependent to the both, not part of it. Here, yes. So in this functional dependency that we are writing here, we are first trying to say what are the functional dependencies in this table, regardless of anything. In this table, if I have the student ID, just rationally, we can see what is the student name, okay? If I have the course ID, I can say what is the credit hours. If I have a student ID alone, I cannot say anything about the grade. Am I right? Because the students can have multiple courses. So if I have just your ID, I cannot say which course and which grade. So the combination, if I have your name, if I have your name and your course ID, I can say, okay, B plus is your grade. Okay. So first of all, this is the functional dependency in this table. Nothing related to the second normal form. Now I am just going and check, and I'm seeing that credit hours is just dependent to the course ID, is not dependent to the both together. In that case, I can say, okay, this is wrong. So one non-key attribute is dependent to the part of the key, not the whole key. Okay, we will see more example, especially at the end, we will work on the some assignments, so it's gonna make more sense for you. But at this moment, that's the rule. Remember, practice, you will learn. No non-key attributes can be functionally dependent on only part of the key. Okay, good. Is it clear already? Yes. And just by practicing more, definitely it's gonna be better. But at this moment, let's go to the uh, third normal form. But just for the violating, the data redundancy, insertion anomaly, updating anomaly are the issues that could happen. So right now, in order to fix this table, we should decompose the table, which we call this process decomposition. We should decompose it to three different tables. One table, just a student ID, a student name. Okay, we have one primary key, and this one is already dependent to it. Course table, course ID, credit hours, dependent, and then the last table, which is the student ID and course ID, which is the composite key, and grade is dependent to the both, not only one. That's the right table. If I have the grade B plus, so this one comes from the combination of the student ID and the course ID. So this means this one is dependent to the whole key, but nothing part of the key, not part of the key. Maybe now it makes more sense when we are decompose the main table to three different tables. All good? Yes? If no, ask me, please. I would be more than happy to repeat it again. So we'll work on it more on the assignments as well. So the third normal form, the most important one. If your table on a third normal form, technically you can claim that your database is normal. Okay? So what was the functional dependency? A to B. A determine B. B is dependent to A. Am I right? Simple. The left one should always be a primary key. That's the simple rule. If this is not the primary key, there is a violation of the third normal form, which means all non-key attributes, which means those attributes that are not primary key. We have one primary key or maybe composite key, whatever that are not non-key attributes. They should dependent to only primary key. If you find some functional dependencies in your table, for example, X determine Y. If this one is not a primary key, there is a violation of third normal form. Okay? See the example. The table is employee ID, skill type, and bonus. Okay? So employee ID determine the skill type and bonus. Am I right? If you know the employee ID, you can see who is the employee, what is the skill type, what is the bonus. Also, if you know the skill type, you can determine the bonus. Okay? Logically, based on this example. So technically, there is a functional dependency between two non-key attributes. Skill type, is the skill type primary key? No. Done. We are violating the third normal form. That's it. Okay? Let's see another example. Again, the issue just with the data redundancy, updating and deletion anomalies. So in order to address it, we have to decompose the whole table to two different tables. First table, employee ID skill type, and the skill type for the primary key of the skill table and the bonus rate. Okay, let's see this example. We have a table called employee table. Okay, employee ID, employee name, department ID, department name. So let's check the first normal form. Is there any issue with the first normal form in this table? So what was the criteria to say that we are making sure that the first normal form is not violated? What? Sorry? Atomic values, which means we shouldn't have multiple values under the column. Do we have? No. So technically this table is in the first normal form. Is it clear why this table is in first normal form for everyone? Okay. Now, the second normal form. So this table, employee ID is the primary key in this table. Do you agree? If I know your employee ID, I can say what is your employee name, which department you are working, and what is your department ID. Am I right? Correct? Correct? So technically, the second normal form is already also okay. So we are not violating the second normal form. However, there is another issue. What is the issue in this table? First of all, there is no composite key here. So we mentioned second normal form most of the times happens when you have the composite key. When you have the composite key, all non-key attributes should be dependent to the whole key, not part of the key. Okay, here there is no non-composite, there is no composite key. So technically we are good with the second normal form. But there is another issue in this table. What is the issue? Check the functional dependencies in this table. So tell me. Exactly. So when you have the department ID, you can determine department name. Department ID, is it primary key? No, done. We are violating the third normal form. Easy. Okay. So in order to address, we just have to decompose this table to two different tables. One table employee table, one table department table. Some minutes for digesting concept. Let's starting again. Normalization process. Why we are doing the normalization process? Because we are making sure to avoid any data redundancy, any type of anomaly in when you're updating data, deleting data, or inserting data. Okay. Example, the customer table with my name, then we change it to the customer sale table with my name, then we change it to the customer table, give my name and one ID, and repeat that ID to the sale table. Okay. So in order to be in a normalized data, we should make sure that we are meeting these three conditions. First one, first normal form. First normal forms, atomic value, which means there shouldn't be any multiple value in column. That's it. Second normal form, all non-key attributes should dependent to the whole key, not part of it. Okay. Example we had here. The credit hours is only dependent to the course ID. It's not dependent to both together. Then we decompose it to these three different tables. Now grade is only dependent to the composite key, not part of it. And the last one, third normal form, all non-key attributes should dependent to the primary key. And there shouldn't be any other functional dependency in the table. Okay. So which means if there is a x to y, which means x determine y, x always should be a primary key. Okay. In this example, department ID, when you have it, you can determine the department name. So technically, there is a functional dependency in this table that the determinant is not primary key. So that's the violation of the third normal form. So if you just remember and memorize these three lines, you are gonna be okay when you are designing a database. Let's read together. All attributes in one table must be dependent on the key. The whole key, nothing but the key. One more time. All attributes in one table, they must be dependent to the key, the whole key, nothing but the key. Okay? So when you are saying all attributes, imagine we have a table X, Y, Z, W. X is the primary key. Okay? Okay? So let's put X and Y as a primary key, as the composite key. Okay? So right now, all attributes in one table, Z and W, should be dependent to the key, the whole key, and nothing but the key. So there shouldn't be any connection between W to Z or Z to W. Okay? So just by memorizing these sentences, you are good to go. So you can say, okay, our database is in a third normal form, so I am good to go. There are other normal forms, but technically, when you're in the third one, you're done. But the last one, fourth normal form, technically it's, let's say, there for having more efficient database. That's it. But again, if you are done with the third normal form, you are done with the normalization process. These things means when you are in a third normal form and you also doesn't have any multi-value dependency. Imagine this table, okay? Faculty name, committee is admission, scholarship, course, IM 101, IM 101, okay? So technically we can say for the faculty name and the course, there is two value. So there is a multiple value dependency. So in that case, we can also decompose this table to the faculty committee table and faculty course table. So that's it. Again, fourth normal form is not a big deal. The most important one is the third normal form. When you are in the third normal form, you are good to go. Okay? So we are done with the normalization. So let us start working on some assignments, and then we are done. But before going to the assignment, any questions so far for the normalization process? What do you think so far about the normalization process? Is it a friendly process? Good. So let's, okay, so let me just answer. So when you go to the chapter third, so in the normalization process, make sure to read the text. So we have assignment 3.1, okay? So let us start some of them together. Just let me share my screen. Okay, so I think so. Okay, so assignment 3.1, functional dependencies test. In this table, the capital letters are the attributes, attribute A, B, like a first name, last name, all the information. And these are the lowercase also, these are considered as a date. Okay? So we want to check the functional dependencies in this table. So let's start with the first one. Column A determine column B, true or false. When we are talking the determining, which means if we have the value of A, we can determine the value of B. Okay, so column A can determine column B or not. No, why? Yes, why? We have one no, why? Okay, what do you think? What do you think? True, why? Primary key, sorry?
Usually on all the way to the left.
No, that's not the case. No, no, that's not the case. Is it true or false? Okay. If A, B, if A is A1, what is the related value? B2. If it's A3, what is the related value? B2. If it's A1, what is the related value? B3. If it's A2, what is the related value again? B3. Maybe because this is A and B, you are not okay with it. The answer is false. Because for one value, we have two different values. That's correct. Okay? Let's consider it in a real example. The first A is the customer ID. Okay? The B is, for example, the SSN of the customer. Okay? Customer ID 1, which is Hossein Mohit, that's the SSN for Hossein Mohit. Okay? Again, we have customer 1, which is Hossein Mohit. But this time we have different value for the SSN, which is not right. Am I right? Correct? Now make more sense probably with the example. So technically for one value, you should have a unique value in the dependent column. Okay, so that's why this one is false. Now let's go to the second one. A to C. A determine C or C is dependent to the A. Now you tell me, is it true or false? A to C. Let's write together. When I have it A as a A1, what is the value for C? C1. When it's A3, C3. When it's A1, C1 again. When it's A2, C1. It's fine. Okay, so here we can see that for A1, we just have one single value. Maybe now you are just thinking about the SSN example, which is not an okay example for this, because if you consider this one as a SSN, so technically the SSN should be only unique. But imagine, for example, this is the state. Customer ID 1 only lives in Georgia, which is I am. Okay, so there could be another customer that also lives in Georgia, which is fine. Okay, so right now we can say this one is third one, A to D. false, because for A1, for customer ID1, there are two different values. One D3, one A3, one D1, right? If you might make mistakes, so just write it. A1 once is D3, once is D1. There is two value for one single value. It is not right. In this case, remember the SSN example. For the Hossein name, there is a two different SSN, which is not right. Okay. For the previous one, remember the estate example. Hossein can live in Georgia. You also can live in Georgia. Okay. And so column A determine E. You tell me. True. A1, E2, A3, E4, A1 again E2, A2 is E2, which is fine. Okay. So true. And the rest of the questions is related to consider the possible primary key. Is column A is the possible primary key for the table X? If in order to be a primary key, all the values should be unique. Simple. This is not unique. There is two A1, so this is not okay. But the only one that is okay for it is the D, which is D2, D3, D2, D1, D4. So there's a unique value for it. So technically, 6 questions already answered with this one. And the last one, the last type of question is the taken together. Column B and D are the possible key. So you should also consider the both. So this one could be the assignment 2.3.3.1. And 3.2, in this case, each relation that you are seeing here, this is the schema version. So this is the employee table with the employee ID as a primary key and the rest of the rest of the attributes. So you need to find which normal form this table has it. Is it, for example, maximum, it has a first normal form, or no, this one also has the second normal form or the third normal form, or none of the above. So for the first table, what do you think? Employee ID, name, address, phone, skills. So first answer me, please. In order to be in a first normal form, what is the condition? What is the criteria? Atomic value. So we shouldn't have multiple values in the table. So first of all, do we see any values here? No. So the question just ask you to just imagine if this is the table and there would be some extra information here, which one would violate it? Would be violated. Okay. So according also to the example that we had, for the skills table, there is a possibility to have multiple skills. So technically, when there is a possibility of having multiple in the table, so we can say we are violating the first normal form. Okay. I'm designing this table and give it to you as a person that are entering the data. I am giving you this opportunity to make a mistake. This is the skills table, a skills column, and you will go through the employee resume and you will see multiple skills. So you just normally enter all the skills for each employee. Okay, so technically you are violating the first normal form. Okay, does it make sense? Yes. So technically, when we are not in this first normal form, we are not going to check for the rest. Technically, this is the none of the above. Yes,
What about something like the whole screen?
because it's one value. Yeah, but skills is multiple. Also, for the phone, could be cell phone, could be work phone, could be also multiple values for it. Not just the skills. Phone is also could be related. Right? And no, even the address is the issue. Maybe it's a home address, maybe it's a work address. It could be. But at the end of the day, technically, this is obvious. In this table, there is an issue. And also, there is another issue in this table. What is the issue? The functional dependency is here. Phone determining the address. Is phone the primary key? No. Also violation of the third normal form. Okay? So none of the above. This table. Worker ID, worker name, spouse social security number, spouse name. In the worker table, there is a functional dependency in this table. If you have the spouse social security number, you can determine the spouse name. Am I right? Is the spouse social security number is the primary key? No. Violation of the 3NF, third normal form. Okay, so far we know that this table is not in the third normal form. What about the first normal form? Yeah, it is okay because there is no possibility to have multiple values for each. So this table is in the first normal form. And for the second normal form, there is no composite key, so we can say this table is also in the second normal form. Okay, so the answer is second normal form. Let's see this table together. Sale table. We have composite key, which the keys are date, customer, and product. Okay. Vendor city, sales representative is the non-primary key. Okay. So there is a functional dependency here. Customer determines sales representative. So sales representative dependent to the customer. Customer is part of the key. Sales representative is not dependent to the whole key. It's just dependent to the part of the key. So we are violating the second normal form. Okay? And also, for the rest, we are also violating the third normal form. Because again, these two, this one is determining the not the whole key. But the first normal form could be okay. Each of them can have a unique value, it can be atomic. So this one, the answer is first normal form. Good. So that's the whole normalization process. When you design your database in a normalized way, in future, you are not gonna have any issue with the data redundancy, all the anomalies and issue with the updating, deleting, and inserting data. Okay. Any question? All good. Whatever I mentioned was clear. Really? Am I good enough? Good. So one more time. Monday, no class. Let me stop recording first.